Hello everyone, I'm Jamie and welcome to another session of VStexpo Services. In this session, I'll be taking you through the process of lighting, rendering and populating some of the elements of the scene. In summary, you'll learn how to set up the 3D scene and rendering parameters for draft renders, create and fine-tune different interior light types in IES web files, populate the rest of the scene using 3DB Asset Manager. Every technique covered in this course is backed by more than 10 years of experience in 3D visualization, post-production industry and popular books published on these key subjects. My methodologies are widely implemented by award-winning visualization companies and famous film studios worldwide. Finally, this class is tailored to intermediate and advanced users of 3ds Max and Photoshop, and for designers, architects, 3D visualizers, 3D artists, or anyone interested in mastering their lighting, rendering, and scene setup skills using 3ds Max and VRay. Also, I'll be setting up the best VRay parameters for testing and final renders with render elements. All my tutorials and courses have custom captions included for those with hearing problems. I have the CC text here to indicate this. To enable the custom captions, simply click on this CC button here. You can watch my videos and courses in Full HD by simply clicking on this button, going to Quality and choosing 1080 pixels option here. This scene was originally created for a client, but made few changes to the scene for the sole purpose of this tutorial. So without further ado, let's start by loading up the VRay rendering engine. To do so, let's start by pressing the Render Setup button to open its dialog. As you can see, it's set to default scanline renderer. To load up the VRay renderer, simply click here and choose the VRay rendering engine from the list. The following step is to begin setting up some of the basic and draft VRay settings for test renders. To start, let's click on the VRay tab, expand the frame buffer rollout parameters and the global switches. Most VRay advanced settings are hidden by default. To enable them, simply click on the default button twice to see all the expert settings. Under the default light, choose the Uniform Probabilistic option from the list. The default value is set to 8, but the value for final renders will be 16 or 32. Because we'll be carrying out few test renders first, the current value of 8 should be sufficient for the time being. Also, if you hover over, you can actually see what this function does. Essentially, it determines how lights are sampled in a scene. This option helps to reduce the light artifact samples and speed up the computation of lights in a scene. Scroll down to the image sampler rollout. The image sampler type is set to progressive. Let's change it to bucket instead. For high resolution renders, users are better off using the bucket type, especially because of strict renders, render time and quality of reliability. Change the default settings to expert by clicking on this button twice. In a minimum shading rate function, change its value to 64. Increasing this value improves the render quality substantially without affecting the rendering time. In the image filter rollout parameters, let's change it to area type. I personally prefer the area type filter, especially because it doesn't generate artifacts in overly bright areas of an image. However, feel free to choose any of the listed filters you are comfortable with. Under bucket image sampler, keep the minimum subdivision to 1 and set the max subdivisions to 100 for universal workflow. The noise threshold value is currently low. This noise threshold value should always be higher than the noise threshold of global DMC. In a global DMC rollout parameters, click on the default button a few times to bring the advanced parameters. The smaller the noise threshold values, the better the render quality. The higher the noise threshold values, the less quality you'll have in your render. The bucket image sampler and the global DMC are the main parameters that control the final quality of a render. For best results, you always need to tweak between these two sets of parameters to achieve the best results, as they are both dependent of one another. If you enable the use of local subdivisions options, these global settings will have less effect and take into consideration the local sample values of materials and lights, which will take a lot longer to render. To avoid this problem, always keep the local subdivisions option unchecked and use the global settings here. Currently, this noise threshold is set to 0.01 and the global DMC noise threshold is set to 0.005. which is lower than the bucket image sampler. This is the way these two noise threshold values should always behave between one another. The bucket image sampler noise threshold should always be lower than the global DMC one. To get faster renders, let's reduce this global DMC noise threshold value to about 0.01 and this one to 0.07. As mentioned earlier, this noise threshold value should always be higher than the global DMC one. Next, we're going to expand the color mapping rollout and change the current type to exponential. This specific color mapping type provides a more photographic look to renders and tones down overexposed or bleached out areas. However, feel free to try different color mapping types you're more comfortable with. Click on the default button twice to enable the expert options. Let's keep the dark multiplier value to 1 and the bright multiplier to 1.0. I'll only tweak these two values if or when it's absolutely necessary. Keep the gamma value to 2.2. Keep the effect background option. In the mode function, always choose the color mapping and gamma option from the list. The main reason for using this color mapping mode is to ensure consistency between what's shown in the frame buffer and what's saved into your hard drive. Scroll up and click on the Show Last VRay frame buffer. More often than not, the render seen in the frame buffer may look different once saved into your hard drive because the gamma values may differ. As mentioned earlier, to avoid this potential problem, always use the color mapping in gamma mode. Also, click on the Customize toolbar and go to Preferences. In the Gamma LUT tab, ensure gamma is enabled and set to 2.2. And the display colors in RGB space function should always be enabled at all times. Next, let's open the GI tab and enable the expert settings. By default, the primary engine is set to brute force. Let's change it to radiance map. The radiance map is a lot quicker to compute and displays less grain than the brute force mode. Let's skip the secondary engine as light cache. For the purpose of this exercise, we're not going to enable the ambient occlusion function as we have previously done in the past. There are instances when it's visually better to add a VRay dirt shader on specific objects in a scene rather than applying the ambient occlusion globally. Next, expand the radiance map rollout parameters and change the current preset from high to low as a starting point. Enable the expert mode to display the advanced settings. Let's keep the subdivisions to 50 and interpolation samples to 20. In the light cache rollout parameters for quick and draft results, let's change the subdivision values from 1000 to 700. Also, change the default settings to advanced by clicking on the default button. Let's check the settings tab and render elements, and back on the common tab. The following step is to create the first camera. Expand the viewport. Under Create panel, click on the Cameras command and choose the standard target camera button. In the top viewport, click and drag the cursor to create the first camera. Let's change this viewport to front by clicking F on your keyboard and change the viewport display to wireframe. Next, right-click on the Move toolbar to display its floating dialog. While the camera is still selected, click on the Modify command panel and change the camera from Target to Free type. Currently, the unit's display is set to millimeters. To change this, simply click on the Customize toolbar and choose the unit setup from the drop-down list. In this dialog, you can change the display unit scale to meters. It's worth noting that this change is only for display purposes and will not affect the scale of the scene. While the camera is still selected, under Y-axis, type in 1.6 to move the cameras up. Because the display unit is now in meters, 3ds Max moves the camera up by 1.6 meters. 1.6 meters is the average eye level for most people. There are times when you might need to lower the camera height slightly to make the composition a bit more appealing. Next, select the perspective viewport and change the viewport to camera by clicking C on your keyboard. Let's adjust the camera height and the overall composition slightly by moving the camera accordingly. Also, to see more scene details, click on the shader text and choose Edge Faces from the list. Maximize the camera viewport by clicking on its toggle. Let's expand the viewport first. Under View toolbar, change it from View to Local to move the camera in a specific direction. As you can see, in Local View, you can easily move objects in a straight line. With a mouse scroll wheel, zoom in a top viewport and move the camera in local axis against the wall. Currently, the camera lens is set to 28mm. Let's change it to about 25 to see if the overall composition will be better. Move the camera forward slightly to ensure the end of the curtain on the right is clipped from the composition. And adjust the camera position a bit further to make the overall composition a bit more appealing. To help put together and build this scene quickly, I've used a plugin called 3DB. As we all know, building a 3D scene such as this from scratch takes ages, especially when you have to go through the lengthy process of modeling, texturing, merging and relinking missing textures. The new Asset Library plugin helps you to achieve all of the above with a click of a button. In this area there's a TV missing. In that area we'll be adding cabinet or chest of drawers. Before we start using this Asset Library plugin, let's first open the Environment and Effects dialog by clicking H on your keyboard, or by clicking on the rendering toolbar and choosing the environment option from the list. Under the exposure control rule parameters, choose the VRay exposure control from the drop-down list. The VRay exposure control is utterly important to help balance bleached out scenes, so never forget to add them. The default values are often okay to start with. There are a few cases when you might be required to decrease the f number and/or the shutter speed to increase the overall brightness of the render. Now that most of the basic settings are set up, we can go to the 3DB Asset Library and begin adding 3D assets into the scene to populate it. First you need to sign up and register with their website. To do so, first Google 3DB as one word and click on their website link. After registering, download and install the plugin. Ensure you don't have the 3ds Max running. After you finish installing the plugin, simply launch it and log in to the app. As you can see, the entire 3D Asset Library is displayed as a list. I personally prefer to display assets as tiles because of the thumbnail previews, which are quickly to navigate through. You can also scroll down to see the entire asset library. The following step is to open 3ds Max and begin dragging and dropping some of these 3D assets into our scene to populate it. Once this 3DB asset library is launched, you'll be able to drag and drop 3D assets that are already purchased or assets that are already inside your account. To filter your own content, simply click here and choose a purchase option from the list. These are all my purchase content. Let's go to the main library by simply choosing to turn the filter off from the list. As you can see, the current balance is 188 credits. To purchase it, simply right click on a thumbnail and choose to buy assets from the list. Enable the Use Real Money option, confirm and buy. By clicking on a downloader, you open this new tab to preview the process of your 3D asset being added into your account. In here, you can also see the progress of your 3D asset being added to your account. As an example, all your purchased 3D assets can be quickly dragged and dropped into your 3D Max scene directly. As you can see, all your textures are automatically linked to where this software was originally installed. To quickly double check whether your textures are linked correctly in 3ds Max, simply click here. Under References, choose to go to Asset Tracking. In Asset Tracking dialog, you can clearly see that under Status it reads OK, which is perfectly linked. As mentioned earlier, this amazing plugin does it all for you with a click of a button. Back in your main scene, let's drag and drop the designer chair previously purchased into your scene. Now that the designer chair is in the scene, let's move and place it accordingly in the scene to complement the entire shot. Next, let's copy this chair by holding down the Shift key and moving the object. In the Clone Options dialog, choose the instance and OK. Right click on the chair and choose to rotate it. Also, move it slightly. Select the camera viewport and maximize it. Next, select both chairs with the carpet and isolate it by clicking the Isolate button. Expand the viewports. In the front viewport, zoom into one of the chairs and move it slightly so it's not sank into the carpet. Let's select the other chair and do the same. Maximize the top viewport and zoom in with the mouse scroll wheel. Change the viewport from wireframe to shaded mode. Next, click on the Rotate tool and rotate the viewport. Zoom in closer to the chair and place its legs just below the carpet. Do it to both chairs. Select the camera viewport and expand it, followed by exiting the isolation mode. Let's adjust the chairs a bit further and go back to the 3D dialog. We're going to navigate the dialog and check other 3D assets to buy. This designer chair would look great in a kitchen area. Back in the 3ds Max, expand the viewports. Type in T on a keyboard to convert this viewport into top one and wireframe. Back in 3D Asset Manager, drag and drop the second designer chair into the viewport. Select and move the chair to the kitchen area. Rotate and adjust the chair to fit properly around the table. In the front viewport, while the chair is still selected, press Z on your keyboard to zoom extent into the chair. Move the chair up to sit on top of the wooden floor. This is how I was able to build the scene very quickly using the 3D Asset Manager. As previously done, let's select the camera first and rename it as _living room and press enter on the keyboard. Next, to copy this camera, hold down the Shift key and move it. Let's rename this new camera as _kitchen and press OK. Next, while the kitchen camera is still selected, select the camera viewport and press C on your keyboard to enable it in the viewport. Move and adjust the camera to create a nice composition. Open the Render Setup dialog. In a Common tab, set up the render output size to complement the camera composition. 4500 pixels in width by 2600 pixels in height seem to have worked perfectly for this camera composition. Also, lock the image aspect by clicking on this padlock. Let's adjust the chair and camera a bit further to frame the composition even better. Next, copy instance few more chairs around the table. To rotate the chair, let's first enable the Angle Snap Toggle toolbar. This will make it easier to rotate the specific angle. Next, move and adjust the chair accordingly around the kitchen table. Also, copy and place one more chair around the table. Let's adjust the camera a bit further to frame the composition even better. From this point onwards, we can continue to use the 3D Asset Manager to populate the scene with more objects. Next, change the current viewport to living room camera view. The following step is to begin creating the lights. To do so, in the Create panel, click on the Lights button, choose the VRay light type from the list. In the VRay object type, select the VRay light. This is a plain light type by default. In the front viewport, click and drag to create the window light. Open the Modify panel and zoom out of the top viewport to find the light in the scene. Move it close to the apartment. Adjust the light so it's placed outside the balcony with its arrow pointing towards the apartment. In the Light Modify panel, increase this multiplier to about 100. Also, rename this light as _window. Next, let's change its color to blue to emulate the blue tint from ambient light coming from outside. Select and hold the color swatch to bring up its dialog. Select the blue hue and move the whiteness arrow up towards the dark blue color and close the dialog. To achieve a specific tone of blue, open the color selector dialog again and type in 150 for hue, 146 for saturation and 177 for value. Close the dialog and increase its multiplier to about 300. In its dimension, in a half length value, type in 4808.6 mm and press enter. Even though the display units are in meters, by typing in mm, 3ds Max will automatically convert the values for you, as you can see. For half width value, type in 1.932.84 mm and press enter. Under options, enable the invisible function. This option makes the light object invisible to the camera when rendering while computing the global illumination. Also, let's disable the effect reflections function to prevent this light object from appearing in reflections and keep the effect diffuse and effect specular. This window light is currently being used as a portal light. The following light we're going to create is the sunlight. In the VRay object type, click on the VRay Sun button. Because we want the shadows to be going in this direction, we're going to click and drag the sunlight object in the top viewport from right to left. Click Yes to the VRay Sun dialog asking to add VRay Sky environment map. While the VRay Sun is still selected, open the Modify panel. To start, let's reduce intensity multiplier to 0.3. Often, when there are white walls in interior scene, it's best to start with low sunlight values and gradually increase them if or when necessary. Next, increase the size multiplier to 2.0. Increasing this value will smooth the shadows and make them more appealing. In the photon emit radius, increase the default values until most of the scene is covered. Select the sun target by first clicking on the Select by Name button and choosing it from the list. Begin moving the sun target further to the back to set its direction. Next, select the sun head. In the front viewport, zoom out and begin moving the sun head upwards. While moving the sun head upwards, ensure the sun target line can be seen in the camera. This line is a clear direction of where the sun will be hitting in the scene. Continue adjusting the sun target and its head to set the direction of the sun and shadows in the scene. Maximize the camera viewport. Because we'll be carrying out quick test renders, let's reduce the render output size to 800 pixels. The height has automatically changed to 462 pixels because the image aspect is currently locked. It's always prudent to save the scenes periodically in case it crashes unexpectedly. We may need to pull the camera back slightly to ensure these recessed lights are part of the composition. As you can see, the overall composition looks much better with these recessed lights inside the frame. In post, we could also crop out this lower part of the frame. Open the Render Setup dialog again to double check some of the rendering settings before we start test rendering. Now that we are happy with the current render settings, let's start with the first test render by clicking on the Render button. While the frame buffer is rendering, enable the History button. This is a quick preview of the overall lighting and colors. We can later change the color of this chair to match the overall color scheme. As you can see, the overall scene is looking bright and with shadows. In terms of composition, we can add more 3D assets from 3DB library. We can also see the sunlight hitting the floor and the wall here. The following step is to create nice and warm coffer lights around the ceiling here, and few VRay IS lights beaming down the walls with patterns. The new artificial warm lights will make the overall scene more appealing, especially when contrasted against these colors. Once we are happy with the overall render, we can cancel it. As mentioned earlier, we can quickly build a scene without having to worry about the materials when using the 3DB Asset Manager. In a frame buffer, click Save to add the current render into the render history. We had to save it manually because by default the frame buffer history was set to automatically save the renders only when they are 100% complete. The frame buffer history is great to preview the rendering progression, minimize the dialog and expand the viewports. In a VRay object type, click on a VRay light button and create it in a top viewport. To restrict the selection to lights only, click on All and choose lights from the filters list. This will prevent us from selecting objects by mistake. Open the Modify panel and change its color to warm yellow. Rename this light as VRay light _ ceiling wash and press enter. Close the dialog. Increase the multiplier to about 100. In a length value, type in 49.337 mm. In a width value, type in 1335.881 mm. In a front viewport, move the light up to the ceiling. In a top viewport, position it accordingly by rotating and moving. Under its modify options, make it invisible and not to affect the reflections. In a front viewport, let's rotate the light up so its arrow is beaming towards the ceiling. Rotate it further in a top viewport. In a front viewport, rotate and move it up further inside the ceiling coffer. And adjust the light a bit further. In a camera viewport, click on a plus sign and choose the 2D pen zoom mode. Zoom in close to the light. Expand the viewports. In a top viewport, change the view to local and stretch the light to fit both ends using the scale toolbar. Select the move tool. Hold down the shift key and move the light to copy instance it. Instance lights are a lot faster to compute and render than copied ones, so whenever possible, always instance lights. Rotate this new light and place it on this side of the ceiling coffer. Stretch this light further to fit this side of the ceiling coffer. Even though this light is an instance, stretching it will not affect the dimensions of other instance lights. Stretching the light with a scale toolbar does not affect the dimensions of other instance lights in a scene in the same way the width and the length values would. Let's copy instance this light to the other side of the ceiling coffer by holding down the shift key and moving it. Rotate and adjust the light as previously done. Some of you might be wondering why not mirror the light instead of rotating it. The simple answer is mirrored lights may generate light artifacts. It is the same with mirror objects. Artifacts such as flip textures, etc. will occur when objects are mirrored, so avoid mirroring objects and lights whenever possible. Copy and adjust this other light here. In a camera viewport, exit the 2D pen zoom mode. Maximize the camera viewport and save the scene incrementally. At times, I use a dialog box to check how straight the verticals and the horizontals are. Let's do another quick test render to see how the scene is progressing. As you can see, the ceiling coffer lights are making the overall scene a lot warmer and appealing. It's worth noting that this color scheme and the overall design was originally chosen by the client. If you want to instruct VRay to prioritize specific areas to render, you can do it with a mouse by simply clicking on this button to track mouse while rendering. In a frame buffer history, you can see the progression between the first and the last render. As mentioned earlier, it's utterly important to have this button display colors in sRGB space enabled. By turning it on and off, you can clearly see the difference it makes. Sometimes the gamma value displayed in this frame buffer isn't what's saved in your project folder. This serious discrepancy will later cause major production problems down the pipeline. To ensure this problem doesn't occur when saving the final renders, simply click this button to duplicate the max frame buffer to compare the gamma display. If the duplicated frame buffer had come out darker or brighter, it would have been an indication that there was a problem with the gamma values. As an example, sometimes the gamma is disabled under a max preferences dialog. When that happens, and you duplicate the frame buffer, the image would have come out darker, as you can see here. This is one of the many reasons there's a gamma discrepancy between what you see in a frame buffer and what is saved in your project folder. There's also another reason why this error occurs. Under VRay color mapping rollout parameters, when you have the color mapping only, no gamma, these gamma value discrepancy errors will occur. The color mapping and gamma should always be enabled from the very start of your scene. This specific function was not available in the previous versions of VRay, therefore gamma problems were more prevalent. So before starting a project, always ensure to have all these options enabled. It's during these render processes that users should ensure everything is working accordingly to avoid any unwanted surprises in the end. The following step is to begin adding VRay IS lights under each of these recessed lights seen here. In a VRay object type group, click on a VRay IS button and click and drag it in front viewport to create it. As you can see, its target is always pointing downwards. Open the Modify panel and deselect the targeted function. This will allow you to move the VRay IS in a scene more freely. In the top viewport, zoom out and move the IS inside a penthouse apartment. Move and adjust the IS light accordingly. When an IS light is close to a wall, it's often best to move it away slightly to prevent the wall being bleached out. To load the IS file, click on the IS file toggle and load it. As you can see, the IS profile immediately changed. Under the IS properties, the current intensity value seems high enough. We need to render it to see whether it's worth increasing or decreasing. If per chance you want to preview the IS light profile before loading it, you can do it by simply going into the Create panel, Lights group, and choosing the photometric type from the list. Select the target light type and creating a front viewport. While the light is still selected, open the Modify panel and turn off the light by clicking on the function. Also turn off the shadows. The light is now not affecting the scene and being used for the sole purpose of previewing the IS web profiles. Under light distribution type, choose the photometric web. In the distribution rollout parameters, click Choose Photometric File toggle and load the IS web file. As you pick the web file, you can clearly preview its web file information in a dialog. This is only possible because you're using the 3ds Max photometric light. Even after opening the IS web profile in 3ds Max, you can still preview the web file under the distribution rollout parameters. Being able to preview the IES web profile allows you to quickly determine which file to choose and load in the VRay IES lights. Let's do a quick test render to see how this light is affecting the scene. As you can see, the IES light is affecting the wall nicely. However, it could look a lot more appealing if its color was a bit warmer. Let's cancel the render and change the IES light color. Select the IES light in the scene and open the modify panel. Select its color swatch and change it to a warm yellow color as previously done. Also, let's move up the IES light slightly and do another test render. As you can see, the overall color is a lot warmer and appealing. Because we'll be adding quite a few of them in the scene, it's probably best to reduce its intensity slightly. In its intensity value, let's change it from 13,172 to 11,172. In the top viewport, let's hold down the Shift key and move the light to copy it. Choose a number of copies across and adjust them accordingly. Copy a few more across. Also, copy instance a few more lights in the kitchen area. In addition, let's use some of the ceiling coffer lights under the kitchen cupboards and on top of them. Selecting copy instance one of the ceiling coffer lights and rename it as _kitchen_wash001. The following step is to move, adjust and scale this light to fit under the kitchen cupboards. Let's copy instance and fit a few more lights under the kitchen cupboards. Next, change the kitchen camera view to the living room one and do another test render. As you can see, the overall scene is looking much better. We can also move the IES lights further away from the walls and higher up, and make a few other changes here and there. Before we start preparing the scene for the final high resolution render, let's add a few render elements first. Open the render setup dialog again and go to the render elements tab. To add the first render element, click on the add button and choose the multi-matte element. Open the material editor dialog. As you can see, each material has its material ID from 0 to 15. I often prefer to use the multi-matte material ID because it affects more objects in a scene than the multi-matte object ID. To set an object ID, you simply select an object in a scene and right click. In a quad menu, choose the object properties option. Under the gbuffer object ID, you simply type in any number and OK to close the dialog. As mentioned earlier, the multi-matte material ID would affect all objects in a scene assigned to this material ID number. The number 0 affects nothing in a scene. It's a lot easier to cover more objects in a scene using the multi-matte material ID than to select individual objects in a scene, right click, go to object properties and type in the specific number. Suppose you have 20 objects in a scene assigned to this material ID. By simply changing this material ID number from 0 to 1, you would automatically cover them when adding the multi-matte material ID render element. The way I would normally do this is to go to the multi-matte render element first, rename the multi-matte render element accordingly. In this case, I would rename it as multi-matte element underscore multi-sub and click enter on the keyboard. By default, the multi-matte render element is numbered from 1 to 3. The number 1 will display R for pure red color. The number 2 will display G for pure green color. The number 3 will display B for pure blue color. These colors are a lot easier and accurate to select in post than the VRay wire color render element. You can check some of my post-production courses here to see how I often use this render element. By this function not being enabled by default, it is automatically affecting the object ID numbers of objects when you right click and enter any number from 1 to the infinite in Object Properties GBuffer ID number as shown earlier. When you enable this function isMaterialID, you are essentially telling VRay to look to material ID numbers in Material Editor instead. So for instance, if this material ID number is number 1, this multi-subobject material ID number can be number 2. As you can see, the material ID number will cover from 0 to 15, whereas the object ID numbers can go from 1 to the infinite. However, this option is more tedious and doesn't apply to attached objects with multi-subject materials. When rendered, the multi-matte render elements will look something similar to this. As mentioned earlier, every multi-matte render element comes in 3 colors when used accordingly: R, G, and B. R is for red, G is for green, and B is for blue. If this multi-subobject material is number 2, this other material ID number can be number 3, and so on. You can quickly go through quite a few materials being used in a scene by numbering them accordingly. For instance, you could cover most objects in a scene by numbering them most metallic materials with 1 number. Wooden materials would be different ID number, and so on. The more you use this render element, the more you'll understand how it works. Back in the render element, rename this multi-matte element as underscore multisub1. We are renaming it differently to have a clear distinction between the 2 types of multi-matte element and to also avoid overriding render element names. To add the next multi-matte element, simply click on the add button and choose the next multi-matte element. Rename this new multi-matte element as underscore multisub2. Because the first multi-matte element set had the numbers 1, 2, and 3, the second multi-matte element set should be 4, 5, and 6. In the Material Editor dialog, enter the material ID numbers accordingly to reflect the new set of multi-matte element numbers. These are mainly for the material ID numbers. To cover the 15 material ID numbers referred to earlier, we need to create 5 multi-matte element sets with different names and numbers from 1 to 15. As mentioned earlier, ensure to enable this function isMaterialID to use the material ID numbers instead of object IDs. After covering all 15 material ID numbers by adding 5 different sets of multi-matte element numbers with isMaterialID enabled, the remaining multi-matte elements need to be based on object IDs instead. As previously mentioned, to use object IDs, you simply need to select an object in the scene, right-click, and enter any object ID number. Again, when the multi-matte element is using object IDs, the isMaterialID needs to be unchecked. To create a multi-matte element for object IDs, simply click on Add button and choose a multi-matte element. Rename this new multi-matte element as underscore object ID 1 and press enter. Select and copy this name to later paste and rename for the next multi-matte element. As mentioned earlier, because this multi-matte element is using the object ID numbers, there's no need to enable the isMaterialID function. Select the curtain and open the group. Select the curtain object again, right click and choose the object properties. In a GBuffer object ID, enter number 2. So that number ID will coincide with this number 2 here in a multi-matte element green color. You can continue to do this incrementally to cover most objects with 1 material in the scene if desired. Next, we can start adding other important render elements such as VRay lighting, VRay luminance, and so on. To select multiple render elements, simply hold down the Control key and select as many render elements as desired from the list. Also, add the VRay glow illumination, VRay diffuse filter, the VRay raw lighting, VRay raw refraction. Never use the VRay raw refraction filter or VRay raw refraction filter, as these will cause your render elements to be completely blown out. Also are the VRay raw render refraction, the VRay raw shadow, the VRay refraction, VRay sample rate, VRay self-illumination, VRay specular, VRay total lighting, VRay wire color, VRay normals, VRay alpha, and VRay bump normals. Also, I frequently use the VRay light select render element. The VRay light select render element should look similar to this image when rendered. This render element allows users to control every single light intensity and color individually when used accordingly. In some of my tutorials and courses here, you can quickly check how to use them in post as a render element. To create a VRay light select render element, simply go to the render element and click Add as previously done. Choose the VRay light select render element from the list. To rename the VRay light select render element, select a VRay light in a scene, followed by selecting the light name, copying and pasting it in your VRay light select render element name. Naming render elements accordingly will later make it easier to select and tweak in post-production. Once named accordingly, in a light's rollout, click Add and select the relevant light in a scene. The light is now added to this render element. Once this render element is rendered, it should look similar to the image shown earlier. It's best to add one VRay light per render element only. Otherwise, you lose the ability to control each light individually in post-production. Also, having too many lights in one VRay light select render element may bleach out your image in post. To create a second VRay light select render element for another light, you simply have to repeat the previous steps. Please watch this tutorial here to download and learn how to use this plugin, or go to ScriptSpot to find a plugin called AutoRe VRay light select render element light select. In a page, you can simply scroll down to download it. This script only works for Max 2016. I have a new version that works from Max 2016 to Max 20. It's only available to those with my courses or my Patreon supporters. Once installed, it should look similar to this. Simply click on this button to open the dialog. By default, it's set to create VRay light select render elements for all lights in a scene. There are options such as current selection and others. I normally use the all lights in a scene option. Before I start creating VRay light select render elements for all lights in a scene automatically, I need to delete these two elements previously created to avoid duplicates. You will start seeing every single VRay light select render element being created automatically in a render element field. Click on the create elements button. You can scroll down to see them all listed. Once rendered, you should end up with a long list of VRay light select render elements named and numbered accordingly as seen here. Again, you can watch my other post-production tutorials here on how to use these render elements in post. Before we send out the final renders, let's set up render parameters for high resolution. Open the render setup dialog. In a common tab, let's increase the output size to 4,500 pixels in width and 2,600 pixels in height. In the VRay tab, enable the VRay raw image file function and click on its toggle. As you can see, a raw VRay image file looks similar to this. This raw image file format also saves out all the render elements. Users can also use this file as a backup in case you lose your render elements, or if your 3ds Max file crashes and you need a region render with elements and etc. In a file name, simply name it accordingly by typing it in. As mentioned earlier, if your 3ds Max file crashes and you need a region render with elements etc., you can simply load the VRay raw image file format and region render the missing areas. For more information on how to use the frame buffer to load VRay image files etc., please check this other video tutorial here. Next, enable the separate render elements option. This option allows VRay to save the render elements when being used. To name the render files, simply click on this toggle here. In this dialog, simply name it accordingly. As you can see, VRay will use this name and automatically add the render element name next to it. Next, choose the file format and set it up. I often use the TIFF file format because they're extremely high in resolution when set up properly. In the TIFF image control dialog, enable the 16-bit color and 300 dots per inch. 300 dpi is quite high, however feel free to go higher if desired, and OK to close the dialog and save. Back in VRay raw image file, you can also enable the VRay image file to save EXRs, DPXRs and dot delimited, while this is still a VRay image file. In a frame buffer, this is where you load the raw VRay image file format. After loading it, you can save out the file, the render elements in any file format you wish, and carry out other region renders. VRay will save the new region render and the entire image as one collapsed image in multiple render elements. This is one of the many reasons it's imperative to always enable the VRay raw image file. In the global switches, under uniform probabilistic, increase its value to 16 or 32 for high-end results. As mentioned earlier, it helps to get rid of light speckles and speeds up the light computation during the pre-passes. Under bucket image sampler, these are the values that will control the final quality of your render and elements. As mentioned earlier, the lower the noise threshold values, the better the quality, but at the expense of longer render times. So in the noise threshold, let's reduce the value to 0.007. This is the maximum value. The minimum noise threshold value, let's reduce it to about 0.004. As mentioned earlier, the minimum noise threshold value need to be always lower than the maximum noise threshold. These current values often work well, however feel free to either go lower or higher if desired. In the minimum subdivision values, increase it to about 4. This is mainly to get rid of light speckles often seen in the VRay light select render elements. Increasing this value increase the rendering time slightly, but will get rid of light speckles often seen in VRay light select render elements. Some users go even higher in some cases. Next, open the GI tab and change the current irradiance map from low to medium. Under light cache, increase subdivision values to about 1000 or 1500. As you start rendering, if per chance you see any light cache artifacts, simply increase it to 1500 or 2000. These sort of artifacts are often black and commonly seen in corners and under objects. It's obviously not apparent in this scene because the value of 1000 seems to work okay. Let's quickly check the remaining settings. I often set the dynamic memory limit to 0 so VRay can use as much memory as possible to render quicker, and leave the remaining setting values as they currently are. If by chance you want to do some region renders before sending the full file to render, simply go to VRay frame buffer and then check the VRay raw image file and the separate render channels functions first, and draw around the area you need to region render. When happy with everything, disable the region render button and check these both functions again. Because this camera is locked to front viewport, let's unlock it. Select the camera view, lock the view again and click render. To send and manage your renders, there's an amazing software called Render Manager from Pulze. It's a quick and easy software to install and allows you to manage your computer's software and renders in a smart and intuitive way never seen before. Render Manager allows you to quickly connect to your computers, check your versions of 3ds Max, plugins and much more before deciding to use any of the listed machines to render. You can quickly do this through the Render Manager interface or use the remote desktop by clicking on this button here. Also, you can select one or multiple computers from the list to simultaneously restart, shut down, wake them up, delete, or to report an error, which will be added into your admin tab. There's also an option to suspend any of the listed computers previously sent to render, or reverse this action by choosing to unsuspend. There's also the night node function, which is applicable to workstations mainly. It turns any available workstation into a render node, which will be added to the render farm. Your own PC can also be turned into a night node by clicking on this button here and be toggled on and off remotely. This button here allows you to reset the job module or restart the whole manager service if and when necessary. To submit a job to render, you can do so via browsing through your directory or via an open 3ds Max scene. It comes with the state-of-the-art functionalities and allows you to preview the rendering process of each machine from its own dialog without having to remote desktop. Renders can be sent as a single frame distributed rendering in tiles or strips. Finally, you have the Analytics and Admin tabs, which provides users with a comprehensive list of the nodes being used, plugins available from each of the listed computers, and much more. To find out more about this amazing software, please check out my resource files and the link descriptions. The final render should look similar to this one after a bit of Photoshop. In the next step, I'll be taking you through the amazing process of transforming this full render into this final one in minutes. Please check the link descriptions to download and watch it. This concludes our tutorial. I really hope you found this one useful, like and share it, and I hope to see you on my next one.
Thank you.